Hello, my name is Michael Wybrow, and in this video I'm going to talk to you about some other Swift basics. So Swift has conditionals and like many other languages, unlike some languages like C, you don't need to have brackets around conditionals. It is possible to do that, but we wouldn't do it most of the time, and it's only really necessary if you need to override operator precedence. Else statements look like this. You can have else if statements as well. So loops in Swift are similar to other languages. Again, brackets are not required. Now, one notable exception is that Swift doesn't have C-style for loops. That is the ones that are structured with an initialization, a condition, and an afterthought. Here are some examples of different Swift loops. Here's a while loop that loops while a particular value is not equal to 50. This is the syntax for a do while loop. It's called repeat while something. And here's an example of a for loop that loops through a series of indices from 1 up to the value 4. So this syntax says this is a number range from 1 to a value less than 5, or a number range from 1 up to the value 5. How we write functions in Swift. So we saw earlier some notable aspects to the Swift language are we don't need to specify types, and usually we just let these types be inferred. We also saw that statements in Swift don't need to have semicolons after them at all. For functions, we can't always just infer the type, or can't infer types, so we need to specify the types as part of the function signature. So this is a function called add52. It has a parameter called number, and that parameter is an integer. Obviously, the parameter is available within the function, and this first function doesn't return any value. Here's an example of a function that returns an integer, and you just use the return statement to return that value. Now, one other interesting point is if you were to make a call to this function, you would need to specify the name of this parameter. And the way that you can avoid that if you don't wish to specify the name of a parameter is that you can make that parameter anonymous, and you do that by putting an underscore. Now you still need the parameter name itself because you want to refer to it inside the function, but this just means when you make a call to the function you don't need to specify it. And look, Swift is designed to be very readable, and often you'll find, especially in Apple's own frameworks, that methods from classes and functions are named in such a way as to make the code readable when calls to that function are written. So, for example, if we weren't going to specify this parameter name as part of the call, we might change the name of the function to be add5 to number, which sort of tells us that the thing that we're passing as an argument is a number anyway. So it's possible to return multiple values from a function. You can do this with a tuple, and obviously the return type here, which is after the arrow, in this case is a tuple, and we need to specify the types for each of the named values within it. So we have less and more here. When we return this, we can just create it with a literal value like we have here. Then when we want to use these individual values that are returned, we could create a variable results, which is that tuple that's returned, and we can then, it has a less property and a more property. Alternatively, instead of having a variable that holds this tuple, you can have the individual values out of it. So we can write syntax like this and then just refer to the two values, which can be quite useful. Here's an example of us making a function call, and you can see that we're specifying the parameter here, like I talked about on the previous slide. So, the way we declare classes in Swift is also different. Unlike some languages, notably like C and C++, we don't have this separation of header files and source files. Swift classes are usually just defined in a separate module, a .swift file, and they're just available to the rest of the project. So we can call methods on a class by having a variable that holds our class instance, and we just say dot and give the method name and any arguments that we need to pass for any parameters that are required by that method. And it's also possible to make class methods. So these are methods that can be called on a class but don't act on a particular instance of the class. And they're defined with this class keyword. And you'll see that normal methods of a class are defined as functions within that class, which we'll see in a moment. And the difference is when you call a class method, you give the type name, the name of the class itself, not an instance of that type. So, Swift has both classes and structures, and they're very similar to each other. So, both of them can have properties, both of them can have methods, and both of them can have initializers, and both can conform to protocols, and that will make more sense when we talk next week. The difference is that classes are a reference type and structures are a value type. So what this means is when you have an instance of a class or an instance of a structure and you put it into a variable and then you do something with it, when you've put it into a variable, in the case of a class, you have a reference to the original. In the case of a structure, you have a copy of that structure, and anything you change on it won't be reflected on the original. Whereas in the case of the reference type, with a class, it will be. Some other differences: structures have a default initializer that's created for them automatically by Swift, so they're very lightweight. You can just specify properties, and then they have a default initializer you can call based on those properties. Both inheritance and typecasting, inheritance and typecasting only work with classes. They don't work with structures. So, in general, we make use of structures and enumerations for custom classes, for custom data types, sorry, and then we make use of classes where they're necessary. So let's have a look at some of these things like structures and also enums. Here's an example of a structure. As we said, it looks a bit similar to a class. You say structure, furniture is the name of the structure, and here are a series of properties. These are done with a var keyword, but they could also have a let keyword. In this case, you need to give the type of each of these, and this could be a string, an int, it could be an optional. In this case, the type of this one is an enum, which is our furniture one up here that has two different cases. It can either be antique or modern. And you can see I can create an instance of this furniture structure, and we didn't create any initialization method, aka a constructor. In this case, it was synthesized for us, and you can see that the default initializer just has each of the properties that are given here, and we just give them in order. We specify the name is chair, the age is 3, and the style is this type here. And the nice thing about this being a strongly typed language, Swift, is as you're typing this, you can sort of go dot and it will give you the choice between modern and antique, because it will know that style is of type furniture style, which is an enum which has these two properties. So here's an example of the class syntax. Instead of struct, we say class. So here's a class called furniture. It has two properties, name, which is a string, age, which is an integer. Here, we create our own initialization method. We do it with the init keyword. We can specify any parameters we want, none or multiple, but we do need within this initialization method to give a default value for each of these, because we're creating an instance of a class. If you didn't have age equals 0 here, it would give you an error and say that you'd never initialized age in the initializer. When we want to create an instance of a class, we do it by just saying var chair is furniture, named chair, and then later if we want to set one of the values of these properties, we can just using this dot syntax to refer to a property. Okay, so here's an example of inheritance. So old table is a specialist version of furniture that has an additional property called price. So by virtue of the inheritance, old table will have all the properties of furniture plus this one here. And the syntax for doing inheritance is when you specify the class name, you give a colon and you give the class you're inheriting from. Here's an example of our initialization method. In this case, for old table, we initialize it with nothing. And the key thing here is you need to call the superclasses implementation of the init method somewhere as part of your init method here. So there's this one initializer we have where we have to specify a name. So it's going to get called here, and we do it by calling to differentiate between this initialization method and the superclasses implementation. We differentiate them via the super keyword here. Now, one tricky thing is when you initialize the value of this property, the one that belongs to old table, it must be done before the call to the superclass. And if you modify anything that is a property of the superclass, you must do it after you've called the initialization to the superclass. And if you get this wrong, the compiler will tell you and warn you about it, but just be aware that that's what you need to do. Here's an example of us initializing this old table, and because old table inherits from furniture, we can refer to any of the properties of furniture, like name and age, on an instance of old table. Here's an example of inheritance when you've got methods. So let's say I have a method called describe. It has a return type string, and that just describes the piece of furniture. And let's say I want to give some additional information in this describe method for my old table that inherits from furniture. Then I can create a describe method that overrides the one from the class we're inheriting from. So in this case, I have to have this override keyword. If I did want to call and make use of this function, again, I could differentiate between the two of them by using the keyword super to call the superclasses implementation. Swift also has closures, and these are things you'll run into quite frequently using the iOS frameworks. A closure is like a block in C, but it could also be like a function in that it can be passed information. One difference with a closure is it can also capture information. So to explain this, and this is really the very basic description of this because we'll talk more about closures in future weeks. Let's imagine we have an array of integer values. So here's an array values. It has 4 integers in it. There's an array method called for each, where you can do something for each element of an array. Now, if you were to look up the documentation for this for each method, it needs to take a function that is given one parameter when it's called. It's called with one argument, which will be the particular value each time it's called, and it will get called 4 times, and that function should return nothing. So we could write a function that did that, and we could pass it to this for each method, or we can pass a closure. And Swift has this syntax where you can just give a block as part of a call, and we'll see that a few times later. But this block from here to here is basically a little function that takes one argument, which is called value, which in this case will be an integer, and it does some piece of code. And in this case, the capturing part we talk about is it can make use of things outside its scope. So we could have a variable called result that we initialize to 0. We call for each. This gets called 1, 2, 3, 4 times. First it adds 1 to the result, then it adds 2, then it adds 3, then it adds 4, and you'll end up with a value of 10 because it's just added each of the 4 values in the array. So want to touch on memory management for a couple of minutes. In some languages, the programmer is responsible for freeing and allocating memory, and that's a problem because if we forget to release memory, we get memory leaks. If we free things and then try and refer to memory, we get things like segmentation faults. So some languages deal with that by just having garbage collection, and then the memory management is done for us, but that can be inefficient in the sense that we can't control exactly when the memory is freed. So iOS uses something called reference counting to manage memory. This is kind of the idea behind it is when you have a variable that refers to something, you increment a reference and say it's referred to by one more thing. When that variable goes out of scope, you reduce the reference count, and when something gets to have 0 references, then you can free it because it's no longer referred to by anything. So traditionally, with Objective-C, you used to have to do this reference counting yourself. So you would actually call a method that would retain and release things. But this is unwieldy. You have to manage it yourself, so we don't want to do it. Now what happens with Swift is that this is done for us, and the compiler is smart enough that it works out this information. And I mention this because we need to know it happens, because occasionally we have to deal with this and give it some additional information to correct its behavior, but the vast majority of times it will just work and you don't need to worry about it. And this is something called automatic reference counting, where basically it will insert the retain and release calls for us. And this means we get the benefit of memory being freed as soon as possible, and there's very little overhead because it's done at compile time by the compiler. Okay, thanks for watching.